Dear students, welcome back. This is Dr. Biju Vasudevan. In this video, we are going to discuss the chapters 5.2, 5.3, 5.5, binomial and multinomial distributions, hypergeometric distribution, Poisson distribution, and the process. Fine. Let's start with the binomial and the multinomial distribution. Bernoulli process, an experiment with repeated trials, each of which has only two outcomes labeled success or failure. Such a kind of experiment is called Bernoulli process. So what is an example? You can toss a coin, obviously only two possible outcomes, head or tail. You write an exam, only two possible outcomes, pass or fail, isn't it? So whenever there is an experiment in which only two possible outcomes are there, yes or no type questions, isn't it? Called Bernoulli process. So the probability P of success, small p, stands for probability of success, and it remains the same for each trial, and the repeated trials are independent. Occurrence of one trial will not disturb the occurrence of the other trial, right? Okay, what else? Repeatedly tossing a coin and notifying whether you decide your success is getting heads, and notice how many success. What's the probability of success? Probability of success is here 1 over 2 for tossing a coin. Then probability of failure, Q, will be 1 minus P. If P is the probability of success, Q is probability of failure, and total probability should be 1. So subtract P from 1, you will get a Q. That's right. Now what is binomial distribution? Perform n number of repeated trials and count the number of successes. For example, you are drawing a card from the deck of 52 cards 10 times by replacing it. First to take one card and notice what is the card, and then replace it inside. Collect another one. In this way, if you collect 10 times, your question is, your success, you are designing your random variable as getting a red card. Only two types of cards are there, isn't it? 26 are red and 26 are black. So when you decide the outputs are only two possible events, then it will become a binomial distribution. It follows Bernoulli trial, isn't it? Bernoulli trial becomes a distribution of binomial. So how many times we get out of 10 attempts, how many times we get red is our counter, isn't it? So x is the discrete random variable which counts the number of x of successes. For each trial, the probability of success is small p, the probability mass function TMF. For every discrete random variable, we can find a probability mass function table. Now here, x values, see, when we take 10 times a card, maybe 0 times we get red card, maybe 1 time we'll get red card, maybe 2 times we can, maybe all the 10 attempts will be ending in red cards. It's possible, isn't it? So x may be starting from 0 ending at 10, and for every occurrence we can find the probability x0, 1, 2, 3, 4 up to 10. We can find a probability of x, which is f of x, isn't it? For every how to find it? This formula should be used. NCX. You can write nx in this bracket, isn't it? This is NCX, and p raised to x, isn't it? How many times success occurs? Check. X is number of success, p is the probability of success. So probability of success to the power number of times success occurred. Now number of times failure, n minus x failure. There are n events. If there are 10 events, if we get 4 success, the remaining 6 will be failures, isn't it? So if x number of successes, if 5 number of successes, then the remaining 5 will be failures, depending upon the case, isn't it? How many of you are doing? So whatever this n minus x will be failure. So if x is known, number of successes, how many times we get success, then remaining will be failures, whatever the number, 10 or 11, isn't it? So Q is standing for the probability of failure and n minus x number of failures. This is the way formula is written. NCX is how many ways out of 10, how many ways x success can happen. If x is 4, first 4 can be the success, or second 4 can be the success, or any combination. So how many, the number of combinations, and then multiply the probability of success x times, probability of failure n minus x times. That will complete the proof of this formula, isn't it? This is the binomial distribution. Binomial distribution is depending on only two information, n and p. What is the size of the sample, and what is the probability of success? If you know only two information, this x is varying, the value of random variable. This x will come here for all the distribution. So mainly this binomial distribution is depending on two information, two parameters, n and p. N stands for the sample size, the 10 times our experiment is done, that is n. P is probability of getting a red card, is 1 over 2, isn't it? 1 over 2, because 26 red cards out of 52, it is 1 over 2. Okay. And there is a fixed formula for mean and variance. We don't need to integrate or find the summation. We just use this formula because these formulas have been derived by using the formula of expectation of x, summation x p of x. X times you construct the table and then multiply x value with the x value with the probability value, isn't it? Do it for all cases and then sum them up. This has been done here to find and then derived as, in this case, if the problem is a binomial distribution, the mean expectation is n times p, and the variance is n times p and q. That is, q can be written in 1 minus p. So another formula, this is the formula, n times p into q. So n times p times 1 minus p. 1 minus p is q. So if I am asking you to find mean and variance for binomial distribution, you don't need to go with this formula. You can directly use these two to get the expected answer, isn't it? Okay, now we go for multinomial experiments. In the previous case, there were only two possible outcomes, but here you are allowed to have n number of outcomes. The binomial experiment becomes a multinomial experiment if we let each trial have more than two possible outcomes. It's not tossing a coin. It is throwing a die. Toss a die. Possibly 6 outcomes are there, isn't it? And doing it for n times. You can say n times you can toss and check what is your expected outcome, isn't it? So when there are more possible outcomes, more than two possible outcomes, and it follows the same pattern of binomial, it becomes multinomial experiment called multinomial distribution. In general, if a given trial can result in any one of k possible outcomes with the probabilities, then the multinomial distribution will give probability E1 for x1 times, E2 occurs x2 times, and Ek occurs xk times in n independent trials. What is this? You want an example? Well, I would like to give let us assume that throwing a die, let's throw a die, isn't it? How many times? Assume we are throwing it, we are throwing it 10 times. There are many probabilities, isn't it? And assume that we can get to see the sample space has 3, 4, 5, 6. When you throw one die, there are 6 possible outcomes, and you are throwing it 10 times. Assuming that the first 2 times you are getting 2, first 3 times you are getting 2, 2 times you are getting 3, and again 1 time you are getting 4, 3 times 5. Last time you are getting 6. Is it 10, 3, 6, 9, 10. We know what is the probability of getting a 2, which is 1 over 6. So every event in this collection has probability 1 over 6. Here every event is of 1 over 6. Every event here is 1 over 6. Only one event. Here again 1 over 6. 1 over 6. The probability is same for everything, but the concept is here x1 event 1 occurs x1 times 3 times. Event 2 occurs 2 times. Event 2 occurs x2 is 2 times. Event 3 only 1 time. Event 3 gives x3, which is 1. Event 4, fourth event occurs. E4 gives x4 is 3, isn't it? Finally x5 is only 5 different events occurred. X5 is 1. When you add this x1, x2, x3, x4 and x5, you will get total number n 10 times. That is given. Now we know the probability of everything. See, what is the formula for some fixed x? So what is the probability of getting such an occurrence? What is the probability of getting such an occurrence? First 3 are 2, second are what means 2, next 2 events are 3, and this way, isn't it? So this can occur anywhere. There are 3 2s, there are 2 3s, there are only 1 4, there are 3 5s, but in any combination they can occur. 5 can be here, 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 in the first position or last position, middle position, somewhere, isn't it? There are many combinations in which we can get 3 5s. Similarly 3 2s, 2 3s, 1 4, 1 6. So how they will be getting combinated? What is the probability of such a situation? That is what called a multinomial distribution. Now here you have capital N, isn't it? So capital N, small n. Small n is number of times, isn't it? K, how many events occurred? K is x5, maximum x5. Isn't it? X1 you start with x1, x5, K is 5. And probability of every event P1, P2, P3, P4, P5. Clear? Now let's see the formula. Then the probability mass function for this case is, see, xk, x1, x2, xk are the values, isn't it? This is the parameter P1 to Pk and n. We know there are P1, P2, P3, P4, P5 we have, and n is 10. When you substitute those values here, you get the answer. N is 10, and see, this term stands for n factorial over this form. We have seen such a term before in the counting principle. Isn't it? Combination permutation, you might have seen this one. Okay. Now this one we can substitute here. N is 10 factorial divided by, right, how many times x1 appeared. Go back. X1 here is 3, x2 is 2, x3 is 1. So 3 factorial, 2 factorial, 1 factorial, again 3 factorial, 1 factorial. That can be written here. 3 factorial, 2 factorial, 1 factorial, and 3 factorial, 1 factorial, isn't it? Calculate this one using calculator. And probability, all the probability of same here. 3 times x1, probability 1, 3 times, 1 by 6, another probability 2, and 1 by 6 1 time, 1 by 6 3 times, and finally 1 by 6. How many times this event appeared will be in the power, so the power 1. Fine. So when you use calculator, you will find the answer. This is a rough example of multinomial distribution we will use in exercise problems. That's right. That's example for a multinomial distribution. Suppose a card is drawn randomly from an ordinary deck of playing cards and then put back in the deck. So with the replacement, you are placing it back. this exercise is repeated 5 times, so it gives your n is 5. What is the probability of drawing one spade, one heart, one diamond and two clubs? You are looking for probability of one spade, one heart, one diamond and two clubs, isn't it? Two clubs. So x1 is 1 spade, x2 is 1 heart, x3 occurs 1 diamond, and x4 there are 4 different varieties of events, isn't it? 4 is 2 times what occurs? Club, 2 clubs. Okay, what is the probability of getting one spade? See, in the card system you must find there are spade cards 13 starting from ace card 1 to 10, jack, queen and king, isn't it? 13 cards. Spade and heart there are again 13, diamond again 13, club again 13. Out of 56 each has 13, 56, 52 I mean there are 52 cards. Out of 52 cards every case gives you 13 out of 52, so it will be 1 by 4. Probability for every one, this probability for first one is 1 by 4, probability for second one is 1 by 4, probability for third case is also 1 by 4. Doesn't matter how many cards you got, getting one club or one diamond will get you probability 1 by 4, isn't it? P4. So we have x1, x2, x4 x2, x1, x2, x3, x4, p1, p2, p3, p4, capital N is equal to 5. Now you know the formula goes here. Isn't it? This formula, the probabilities are 1 by 4, isn't it? Okay. Therefore, this is it. 5 factorial over first occurs one time, second occurs one time, second event, third event also one time, fourth event the clubs, 2 clubs, isn't it? So this is to be found by using factorial. What is 5 factorial? Multiply up to 5, 1 into 2 into 3 into 4 into 5, which is 120. 1 factorial is 1, 1 factorial is 1, 1 factorial is 1, and 0 factorial, if there is any, it should be 1. 2 factorial is 2, 1 into 2, isn't it? So which is, and now multiply all the probabilities. 1 by 4, 1 by 4, one time, 1 by 4, one time, third event occurs, fourth event occurs twice, so power is 2. Now when you solve this one using calculator, you get this probability. Now I think the idea of multinomial is clear. For binomial it's very easy. We will give right example from the exercise. Exercise starts now. First problem is problem number 5.4. In a certain city district, the need for money to buy drugs is stated as the reason for 75% of all the thefts. See, the city police is dividing the reason for theft into 2 cases. One is money to buy, need for money to buy drug, and the other is everything else. So only 2 possible outcomes. If they consider a theft, they consider into 2 cases. One is need for money to buy the drugs or anything else. Second case is anything else. So what is our random variable x is dealing with this one, need for money to buy drugs. So what is the probability of that one? 75%. Probability small p is 75%, which is 0.75. We got probability of success. You know, after binomial distribution needs only 2 information. What is the sample size n? What is the prob? And x associates. X is for all variables, all distribution. Find the probability that among 5 theft cases, that will give us n. N is equal to 5. 5 cases. What is the probability that exactly 2 is our case? exactly 2 from the need for money to buy eggs, and at most 3. What do you mean? At most 3. What do you mean by at most 3? Maximum 3. So let's see the formula of binomial distribution. P of x is equal to x. Binomial formula is small n c x, p of probability of success to the power x and probability of failure to the power n minus x. And the maximum n here is 5, isn't it? So x can take 0 to 5, any value. Can be no case in our condition. There can be all the 5 cases will be following the same case, isn't it? Okay, now first one, probability of x is exactly equal to 2. Exactly equal to 2. So small x value is 2. N is 5. 5c2, probability of success 0.75 to the power 2 times, isn't it? And q is, if p is 0.75, what is q? Q is 1 minus p, which is 1 minus 0.75, which is 0.25. 0.25 to the power n minus x. N is 5, x is 2. 5 minus 2 is 3. And what is 5c2? 5c2 is 5 times 4 divided by 1 into 2. So 2 and 4 can be calculated 2. Answer is 10. This is 10 times 0.75 whole square, 0.25 whole cube, and use your calculator. The answer is 0.879. Check your answer. Okay, let me try second part. You remember this information. Probability P is 0.75, Q is 0.25, N is 5. Only X varies. Second, at most 3. What do you mean by at most 3? Probability of X, maximum 3. So less than or equal to 3. X can take any value less than or equal to 3. And we know X starts from 0 and ends at n. N is 5. So n 2, 3, 5, x takes value. So x less than or equal to 3, we have to write the formula. N is 5cx, p is 0.75 to the power. Okay, it's not the formula actually. I am writing general formula. What is the probability of x is equal to x here? 5cx, p is 0.75 to the power x, q is 0.25 to the power 5 minus x. X values, isn't it? So this is a different way. Probability of x less than or equal to 3, that is clear. So x less than or equal to 3, what are the values of x? Probability of x is 0, probability of x is 1, probability of x is 2, and finally probability of x is 3. You know, the distribution table, if you write, there will be x 0, 1, 2, 3, 4, 5. As our n is 5, it will end at 5. There will be probability for every case, isn't it? We can find by using this formula. Okay. So if you want probability of x less than 3, we need to add all the probabilities up to 3. Or we can find the probability of 4 and 5, subtract from 1. Both are equal, isn't it? We can find probabilities of 4 and 5, add them, isn't it? And subtract from 1, which will give you this part. Or directly find sum of these probabilities. Write in the formula. In this formula, formula 1, use x value is 0 for first case. For second case, use x value is 1, x value is 2, 3. That's it. In the equation number 1, we are going to use them. Okay. So what we get here right now is first case x equal to 0 in this equation. 5c0, 0.75 to the power 0, 0.25, 5 minus 0, 5. This is for x equal to 0. X equal to 1, 5c1, 0.75 to the power 1, 0.25 to the power 5 minus 1 4. Third, 5c2 0.75 to the power 2, so it's 0.75 degrees increasing. 0.25 5 minus 2, it is 3. The last term 5c3 0.75 cube x equal to 3 and 0.25 to the power 5 minus 3 is 2. Now these terms can be calculated by using calculator. What is 5c0? Always remember nc0 is 1 and ncn is also 1. So 5c0 will be 1, 5c1 will be nc1, nc1 is n, ncn minus 1 is also n. Which, for example, 5c1 is 5, 5c2 calculate it. I am solving here. 5c2, 5 into 4 divided by 1 into 2, which is 10. This will become 10, and 5c3, which is nothing but 5c2. 5c2. You can write 5c2 and 5c3 because there is a rule. NCR is equal to NCN minus R. See, n minus r plus r will be n. So 5c2, this is r. 5c, 5 minus 2 is 5c3. So 5c2 and 5c3 are same. You will get 10 here again. Or you can calculate 5 into 4 into 3 divided by 1 into 2 into 3. 3 will be cancelled. 5 into 4 divided by 1 into 2 will be again 10. Calculate and then multiply by using calculator. The answer will be 0.3672. Okay. Let's go for the next problem. 5.8 from the textbook. According to a study published by a group of University of Massachusetts, sociologists, approximately 60% of the Valium users in the state of Massachusetts first took Valium for psychological problems. Find the probability. This is MIT, now most popular technical university, number 1 technical university in this world. Okay, MIT, Massachusetts Institute of Technology. The University of Massachusetts. Okay, it's University of Massachusetts. Approximately 60% of the Valium users in the state of Massachusetts first took Valium for psychological problems. So our random variable x deals with those who take Valium take Valium for psychological problems. This is our success, isn't it? X. And what is given? 60%. For this, the percentage is 60%. The probability of success 60% is 0.6. Therefore, obviously, Q will be 1 minus P, which is 0.4. Now, we need N as well, isn't it? Find the probability that among the next 8 users, this will give the information about N. N is 8. Among the next 8 users from the state who are interviewed, exactly 3 began taking Valium for psychological problems. So first case, probability of X is equal to, capital P stands for this probability distribution, small p stands for the probability of success. Probability of X is equal to 3, exactly 3. And what is the formula for here? If probability of X is equal to X, in this case, N is 8, so 8Cx, P is 0.6 to the power X, Q is 0.4 to the power 8 minus X. In this case, this is the formula. N has been replaced by 8. So x is 3. Substitute the value of x in this equation number 1. 8c3 0.6 to the power 3 0.4 to the power 8 minus 3, which is 5. Which is 5. So what is the answer? Use calculator. 8c3. You should have known how to calculate 8c3. 8c3 is 8 into 7 into 6 over 1 into 2 into 3. And this 6 will be cancelled. 8 and 7 will be 56. So this is 56 0.6 to the power 3 and 0.4 to the power 5. Use calculator to multiply all these things. The answer is 0.12386. Let's go for second case. Second case, probability of at least 5. At least 5. And the maximum is 8. So x is varying from x, small x value starts from 0 and it's at 8. There are 9 possible values for x, isn't it? But here x at least 5 means capital X should be greater than or equal to 5. You can add from 5 to 6. See, there will be x 0, 1, 2, 3, 4 up to 8. If you want at least 5, you have to add from 5 to 8 all the probabilities. Otherwise, you can find up to 4, subtract from 1. Both are equal here, no problem. So, greater than probability of x greater than or equal to 5, which is at least 5. So the probability of x is equal to 5 plus probability of x is equal to 6 plus probability of x is equal to 7. Now probability of x is equal to 8. Or you can write 1 minus probability of x less than 5, which is 0 to 4.
Excuse me, doctor, are you there?
Yes, I'm here. Okay. Okay, for p of x is equal to 5, substitute x is equal to 5 in equation number 1, you will get 8c5 0.6 to the power 5 and 0.4 to the power 8 minus 5, which is 3. For x is equal to 6. 8c6 0.6 to the power 6 and 0.4 to the power 8 minus 6, which is 2. Plus for 7, 8c7 0.6 to the power 7 and 0.4 to the power 1. Finally 8c8 is 1. 8c8 is 1 and 0.6 to the power 8, 0.4 to the power 0 will be 1. Use calculator. And 8c5, you should know what is 8c5. 8c5, which is equal to 8c3, because 5 and 3, 5 plus 3 is 8. Calculate 8c3, 8 into 7 into 6 divided by 1 into 2 into 3, 56. So this is 56. Let's see 6, which is equal to 8c2, which is 28. Calculate it. 8c7 is equal to 8c1, which is 8. Now use calculator, you will find the answer as 0.5941. So the next problem. In this problem, the probability that the patient recovers from a delicate heart operation is 0.9. So probability of success is small p is 0.9. What is the probability that exactly 5 of the next 7 patients having this operation survive? So totally there are 7 patients, out of which exactly 5. So n is equal to 7 and x is equal to 5. So survival or not, only 2 outcomes. So that is binomial distribution. Therefore, first let's write the probability of x is equal to 5. Under binomial distribution, it is 7c5. Probability of success is 0.9 to the power 5, and failure is q. Q is 0.1. 0.1 power 7 minus 5, which is 2. Therefore 7c5, you remember 7c5 is equal to 7c2. Whenever this 5 and 2 is 7, they are equal, isn't it? N, this is n, this is n minus r. Okay, so it is 7 into 6 over 1 into 2, which is 21. So this is 21 times 0.9 power 5 and 0.1 power square is 0.01. Use calculator, you will find 0.1240. The next problem is the probabilities are, there are 4 probabilities, 1, 2, 3, 4. Call it P1, small p2, small p3, and 4, p4. There are 4 probabilities respectively that a delegate to a certain convention arrived by air, by bus, automobile, or train. There are 4 modes of transport. So 9 delegates are arriving. Totally 9. So n is equal to 9. And out of this 9, x1, first category, arriving by air. How many of them are arriving by air? 3. Second category, x2, arriving by bus. So this is air, this is bus. 3. Automobile, x3 is 1. And fourth category, train, x4 is 2. So 2. Okay, there are 4 categories. Now the question is, what is this? What is the probability of all this x1, x2, x3 and x4? This is multinomial, isn't it? The formula is n factorial n factorial over x1 factorial, x2 factorial, x3 factorial, x4 factorial here into p1 to the power k, p1 power x1. x1 is p2 to the power x2, p3 to the power x3, and p4 to the power x power 4. So n factorial is 5 factorial, 5 or 9, 9 factorial is x1 is 3, 3 factorial, x2 is 3, again 3 factorial, 1 factorial, and x4 is 0.1, 2 factorial. This is 2 factorial, and now probability 1 is 0.4 to the power 3 and 0.2, probability 2 to the power 3, 0.3, probability, third probability is 0.3 power x1, x3 is 1, and 0.2, the 0.1 is the last probability to the power 2. Use calculator. 9 factorial, you have to find 9 into 8 into 7 into 6 into 5 into up to 1, isn't it? Just calculate calculator, and the answer is 0.0077. Next, assuming that 6 out of 10 automobile accidents are due in mainly a speed violation. So we are dealing with automobile accidents. We separate into only 2 cases, either speed violation or some other cases. Isn't it? Only 2 cases. So it's under binomial distribution. So what is the probability? Probability is 6 out of 10, which is 0.6. n automobile accidents among n. So n is 8. There will be 6 will be due mainly to speed, exactly 6. So probability of x is equal to 6 under binomial distribution nc 6 p power x q power n minus x, isn't it? N is 8, 8c 6, p is 0.6 to the power 6, and if p is 0.6 then q is 0.4, and 8 minus 6 is 2. 8c6 is equal to 8c2, which is 8 into 7 over 1 into 2. 4 7s are 28. This is 28. 0.6 to the power 6, 0.4 to the power 2, and the answer is 0.2090 is calculated, right? And the next one is hypergeometric distribution. Here, in case of binomial distribution, independence among trials is required. Every trial is independent of the other trial. So here replacement. As a result, with the distribution, if the distribution is applied, we say sampling from a lot of items. The sampling must be done with replacement. We must have noticed when we pick one card, we will replace it back. We will put it in the same deck, isn't it? But here in hypergeometric distribution, it can be done without replacement. No need to be independent. They can be dependent, right? So on the other hand, the hypergeometric distribution does not require independence and is based on sampling done without replacement. This is the highlight. The previous case with replacement is mandatory for binomial and multinomial. Here without replacement it will be, and maybe dependent or not, doesn't matter. We are interested in the probability of selecting x successes from the k items labeled as successes. See, there will be totally n items, out of which we will select only small n. Not a population, is another sample, big sample. From big sample we get a small sample n here, and in this k x in this n there are k successes. This k are successes and the remaining n minus k are failures. So n, small n, will have both success and failures. It will collect x as success, the remaining n minus x as failures. So x out of k, n minus out of n minus k, n minus x is out of n minus k, isn't it? We will form a small sample, small n. This is the picture of hypergeometric distribution. Now, what is the probability to get some x number of successes? X number of success. N minus k. See, n minus k, n minus x failures and n minus k items labeled failures when random sample of size n is selected from n. This is known as hypergeometric experiment, that is one that possesses the following two properties. What are the two properties? A random sample of size n is selected without replacement from capital N items. Of the n items, k may be classified as successes and n minus k are classified as failures. So again, this is the big sample and there are n items and it has been classified into two parts. There are k successes and n minus k are failures. The remaining parts, if you remove k from n, then remaining is n minus k are failures. Now we take a small part n that has both successes and failures, here and here, right? We call the successes x, so failure will be n, small n minus x. This x from k and this n minus x from n minus k, capital N minus k. These are the properties of hypergeometric distribution. The number x of successes of hypergeometric experiment is called a hypergeometric random variable. So accordingly, the probability distribution of the hypergeometric variable is called a hypergeometric distribution and its values are denoted by C. H of x, x is always coming for all these distributions. X takes the random value, isn't it? Value of the random variable. The parameters are only three: capital N, the big sample size, and small n, some small sample, and how many successors are there in the capital N, big sample, isn't it? Only these three information we want. Then we can find a probability of this x, which is coming up. The probability mass function of the x is this one. What is all this? N, and you will get three information. What is the big sample, what is the small sample, and how many successes are there in N, capital N. So K, and you will choose some value for x, number of successes. We are looking for the probability of x. So KCX, this is small KCX, and this one is N minus K C N minus x, and this is NCX. So multiply these two and divide by this will give you the probability of the hyper geometric random variable x. Alright, let's go ahead with the exercises. So here, finding mean and variance. The formula for mean is n times k over n. Variance, the multiplication of these three terms, and mostly we will not use the formulas of variance. Just for understanding the formula or to answer in the theory type questions, you may use it. So mean is important. N times k over capital N, small n times k over capital N is our expected value. Mean. Okay, now the first exercise is coming up, and remember the formula for probability of x equal to small x. What is it? KCX n minus k c small n minus x. That is, the meaning is x success from k successes, n minus x failures from capital N minus k failures, isn't it? Divided by NCN, small n from capital N, that is NCN, isn't it? This one. So from this information, what we get? A homeowner plants 6 bulbs at random from a box of containing 5 tulip and 4 daffodil bulbs. Totally 5 tulip and 4 daffodil. Capital N is 9, and he plants only 6 bulbs. So 6 bulbs, that's small n is equal to 6. Now what is our success? Getting tulip bulb or daffodil bulbs? The probability that he planted 2 daffodil. So success is daffodil. Capital X is planting daffodil bulbs. So how many successes are there in this n? That is our k. What is our k? How many successes out of 9 bulbs? How many of daffodil? 4. K is 4. Okay, we got 3 information: capital N, small n, and k. We can go ahead with the hypergeometric distribution if you are given some x values. Question is, what is the probability for x is equal to 2 daffodil, isn't it? Probability capital P of x is equal to small 2 for hypergeometric distribution. It is n k c is 4 c 2x 4cx into n minus k. So what is n minus k? N is 9, k is 4. So 5c n minus x. N minus x is here. N minus n small n 6. X is 2. 6 minus 2 is 4. Isn't it? Product divided by capital N C small n. Capital N is 9, C small n is 6. Now only combination. Find what is 4C2. Let's find here. 4C2. 4 into 3 over 1 into 2, which is 6. 5C4 is equal to 5C4 is equal to 5C1, which is 5. So the numerator is 6 into 5 divided by what is 9c6. 9c6 is equal to 9c3. 6 plus 3 will be 9, isn't it? So 9 into 8 into 7 over 1 into 2 into 3. So we can cancel this one 4, this one 3. It will be 84. So 6 into 5 divided by 84. 30 over 84. 30 over 84, which is 5 over 14. The first answer. 5 over 14 is the answer, right? Should we get the answer? The next problem. 5.31. Okay. Solution starts here. What is the question? A random committee of size 3 is selected, a small sample, isn't it? N is 3. From 4 doctors and 6 nurses, the big N is 4 plus 2, which is 6. Write a formula for the probability distribution of the random variable x representing number of doctors. Number of doctors is our x. Capital X is number of doctors is our success, isn't it? So K is number of doctors. Okay, how many success? Random variable is number of doctors. So which will give the success? Success is K. K is 4. Because it's given number of 4 doctors here. Isn't it? K is 4. Capital N, small n and capital N, small n and K. We got it. Now finally find the probability that x lies between 2 and 3, including 2 and 3, isn't it? First case, write the formula. Probability of x is equal to x, which is you should remember the formula, which is kcx n minus k times cn minus x over capital NCX, capital NCN. When you substitute the values, k is 4, 4cx, n minus k, capital N minus k is capital N is 6 minus 4 is 2, c, small n is 3, 3 minus x, n minus k. Okay, 2, 3 minus x. So x must be minimum 1, not 0, isn't it? Okay. Divided by x is this is n minus x. N is small x 3 minus x. X can be anything. Okay. Now capital N is 6 c 3. That is the formula. Now the question is probability of 2 less than or equal to x less than or equal to 3. 2 and 3, we have to add probability of x is equal to 2 plus probability of x is equal to 3. In this equation, substitute x equal to 2. What do you get? First term 4c2 into 2c1 divided by 6c3. What is 6c3? 6c3 is equal to again 6c3. So 6 into 5 into 4 over 1 into 2 into 3. 20. 20 in the denominator. Plus again 6c3 20. 4c3 into 2c0. And 4c2. What is 4c2? 4c2 is 4 into 3 over 1 into 2, which is 6. 6. 2c1 is 2. So this is 6, this is 2. It is 12 first term. Second. 4c3 is 4 because 4 is equal to 4c1. 2c0 is 1. So 4 divided 16 over 20, which is 4 over 5. That is for hypergeometric distribution. Next we are moving to Poisson distribution. Poisson experiment. The numerical values of a random variable x, which counts the number of outcomes in a given time interval or in a given region. The number of traffic accidents per hour in Jubail is Poisson distribution. Number of errors per square meter of a company's linen. Some branded cloth you take, how many errors you can find in a branded error. So when you notice all the examples, the number of typing errors per page in a standard textbook and bacteria is given in a culture, you understand one thing. Poisson distribution or Poisson process is a process that occurs very rarely. Not very often. So when you identify the examples of Poisson distribution or Poisson process, that is very clear that this process is not very often happening. It's happening very rarely. So the probability will be very near to 0 and number of outcomes will be infinitely larger. When you substitute p is 0, n goes to infinity in binomial distribution, you will get Poisson distribution. So Poisson is a limiting version of binomial distribution. This is good for large samples. Binomial is good for small samples. So a Poisson experiment is derived from the Poisson process. Properties of the Poisson process. The number of outcomes occurring in one time interval or specified region of the space is independent of the number that occur in any other time. Just like binomial, it is independent. In this sense, we say that Poisson process has no memories. That has a property called memoryless property. The probability that a single outcome will occur during a very short time interval or in a small region is proportional to the length of the time interval, the size of the region, and does not depend on the number of outcomes occurring outside this time. So it's depending on the interval, not about beyond the interval, time interval or region length, depending on. The probability that more than one outcome will occur in such a short interval or fall in such a small region is negligible, very small probability. Probability of an outcome is more than one outcome. Probably one may occur in this interval. To get more than one outcome, one event in the same time interval is very rare. So it's very negligible. Number x of outcomes occurring during a Poisson experiment is called Poisson random variable, and its probability distribution is called Poisson distribution. So its mass function we are going to see. The mean number of outcomes is computed from lambda times t, where lambda is the average. When t, actually lambda is the parameter for average, and when t is time parameter, where t is time, distance, area, or volume of interest. Mostly it will be time. It will be in all our problems. T will be 1 unit, either 1 hour, 1 second, 1 millisecond, 1 day, 1 month, 1 year. Anyhow, it will be 1. So time will be 1 unit in all other problems coming. Since the probabilities depend on lambda, this notation is called lambda. The rate of occurrence of outcomes shall denote the probability. This is the probability. Probability is depending on only lambda and t. T mostly will be 1, so the parameter is lambda. X will always be there. So what is the formula for the probability? Poisson distribution of the probability distribution of the Poisson random variable x representing the number of outcomes occurring in a given time interval is given as e raised to minus lambda t to the power x and x factorial. In other words, you can write e raised to minus lambda to the power x factorial, and x starts from 0 and keeps going up. In binomial it will end at n, but in Poisson it will not end, it goes to infinitely larger. Why did I ignore t? Mostly t will be 1 in all cases in our discussion, right? So we can use this formula also directly. e raised to minus, everything is depending on the lambda. If you know what is lambda, lambda is the average, mean of the Poisson distribution. Mean and variance both are lambda in this case. So what is lambda? What is e value has been given? Average number of outcomes per unit time is lambda. Distance, time, distance, area, whatever it is. Another information here, mean and lambda both are mean and variance both are lambda times t. When it is unit time, it will be just lambda. Let's take another example. Theorem. There is a theorem. Let x be a binomial random variable with property mass function b, and in that mass function, when you take n goes to infinity and property is very near to 0, n is highly larger, very big, and p is very small, and np is average, product of this n and p is your average, remains constant, then a binomial distribution becomes a Poisson distribution. So binomial becomes Poisson when n goes to infinity, and n goes to infinity, obviously this will happen. We say that Poisson distribution is a limiting distribution of the binomial distribution. We start with exercises. Only the same concept, formula differs. An inventory study determines that an average given is average lambda, isn't it, for unit time. Lambda demands for a particular item at a warehouse are made 5 times per day. Lambda is 5 times per day, 1 day, isn't it? So t is 1. No need to repeat again t. What is the probability that 1 day? So what is the probability that on a given day this item is requested more than 5 times? A. Probability of x greater than 5, and we know in Poisson cases x starts from 0 and it will not end at 5, it will go to infinity, larger. So x greater than 5, if you start counting from 6, where would you end? You will not end. So the other way is 1 minus probability of x less than or equal to 5. In this way you can solve it, which is 1 minus probability of, first write the formula. What is the probability of x is equal to small x, e raised to minus lambda, t is 1, isn't it? Lambda to the power x, because lambda and t is 1, and x factorial. Lambda is also given 5. Your calculator will give the value of e power minus 5. So here x is less than or equal to 5. First probability of x is 0 plus probability of x is 1 plus probability of x is 2 plus probability of x is 3 plus probability of x is equal to 4 plus finally probability of x is equal to 5. We want greater than 5. So when it is greater than, the equality will come in this side. If equality comes here, equality will not be here, right? That's right. Now find these 5 probabilities, sum them up, subtract from 1. 1 minus, what is p of x equal to 0? Substitute x equal to 0 here. E raised to minus lambda, lambda is 5. Lambda 5 to the power 0 divided by 0 factorial plus e raised to minus 5 is common for all terms. Check. 5 to the power 1 divided by 1 factorial for x equal to 1. X equal to 2. E raised to minus 5, 5 square divided by 2 factorial. Next, x equal to 3. E raised to minus 5, 5 cube divided by 3 factorial. And finally, e raised to minus 5, 5 raised to 4 divided by 4 factorial. And for 5, x equal to 5, e raised to minus 5, 5 to the power 5 divided by 5 factorial. So it goes on 1 minus e minus 5 is common, take it out. First term is 1, second term is 5, third term is 25 over 2, fourth term is 5 cube, 125 over 6, fifth term 1, 2, 3, 4, 6 terms are there, the fifth term. E raised to minus 5 is commonly out, 5 raised to 4 is 625, 625 over 4 factorial is 24 plus e raised to 5 will be 3, 1, 25 divided by 5 factorial is 120. Now sum all the terms inside the bracket. Multiply with e power minus 5. Use all in calculator. The answer is 38 0.3840. Check your answer, right? Sum all the terms inside the bracket using calculator. Multiply with e power minus 5 and subtract from 1. You will get this answer, 0.3840. The next problem, no, second case, not at all, 0, x is 0, isn't it? Okay, probability of x is equal to 0. Write the problem, e raised to minus lambda raised to x divided by x factorial. X is 0, e raised to minus 5, lambda is 5, 5 power 0 divided by 0 factorial, and e power minus 5, because 5 power 0 is 1, 0 factorial is 1, which is 0.0067. so you can use this result in the previous slide. Okay, I erased that one. So e power minus 5 is 0.067. Part B is done. Let's go for next problem. On average, 3 traffic, so this is average, which is lambda, average is lambda per month, so unit time, t is 1 month, occur at a certain intersection, some junction, isn't it? In this, what is the probability that in any given month at this intersection, probability that exactly 5x. So first write the probability of x is equal to x is, in the case of when average is given, it is Poisson, isn't it? E raised to minus lambda to power x divided by x factorial. Case A, exactly 5, p of x is equal to 5, e raised to minus, so lambda is not 5, it is 3. I'm sorry, we had to come out of the previous problem. In the previous problem lambda was 5, in this case lambda was 3. Lambda is given as 3, so e raised to minus 3 raised to 5x is given as 5 divided by 5 factorial. So e raised to minus 3 into 3 power 5 is 243 divided by 5 factorial is 120. You can simplify 0.10082. Use the value of e power minus 3 using calculator to find this one. Part B, fewer than 3 accident. Fewer than, it's not 3, it's lesser than 3, isn't it? Probability of x less than 3. Okay, obviously add from x equal to 0, x is equal to 1, and probability of x is equal to 2, not 3, because lesser than 3, fewer than 3, lesser, not lesser than or equal to 3, so it ends at 2. When x equals 0, in this formula, e raised to minus 3 and minus 3 power 0, lambda is 3, 0 factorial plus e raised to minus 3 power 1 over 1 factorial plus e raised to minus 3 square over 2 factorial. The first, e raised to minus 3 is common. The first term gives 1, second term gives 3, third term gives 9 over 4.5. So totally 8.5 times e raised to minus 3. Calculator will give you the answer 4232. Now the question is, what is C? At least 2 accidents will occur. At least means minimum. So when you count from minimum to, you may end it infinitely larger. So how to solve it? At least the case C is at least. So minimum to maximum anything. We will write 1 minus probability of x. Here equality available. So in this side equality available, this side avoid equality. X x and opposite sign. This is greater than, it is less than. Probability of x less than 2. Less than 2 is 0 and 1. That's it. So 1 minus probability of x is 0 plus probability of x is 1. 1 minus x is, what is the formula? 1 minus, open the bracket, lambda e raised to minus lambda, lambda is 3, minus 3, and lambda power 0 divided by 0 factorial, plus e raised to minus 3, 3 to the power 1 divided by 1 factorial. 1 minus e power minus 3, first time will give you 1, second time will give you 3. So 1 minus 4 times e power minus 3, and use calculator, you will get 0.8009. That's the end of this chapter. You can find answers here. This will be in the next video. Thank you very much.